So the first part, if we want to perm hair or we want to make repeating patterns of disulfide bonds in our hair's keratin, right, is going to have to be, well, we need thiols, right? That's the first thing automatically. Everything else follows because it has thiols in some way, right? So, number one, apply a thiol-containing reagent and gentle heat. You know you have to have the thiol because we're putting a thiol on there, right? We know we need some sort of heat probably because, well, we're going to need energy to make the reaction occur, right? Okay, cool. Well, the next part, well, we have the straight keratin, right? So keratin has disulfide bonds in it. So if we're going to make new disulfide bonds that are going to give it a curly structure instead of just the straight, well, we need to break the ones it has, doesn't it? Because obviously they were not arranged in a curly structure, or else the person wouldn't be asking for a perm, right? So, yeah, you got some nice girls going on, don't you? That's okay. It's this, I mean, same basic thing. It's just your naturally occurring disulfide structures just happen to give you perm, or, you know, curls. Okay, so keratin's disulfide bonds obviously need to break then, right? Because we're going to need to form the new ones. So once we've broken the structure, we need to put it in the shape we want, right? So when we reconnect the structure, it'll stick. Does anybody know why we can't wait? Like, why couldn't we put like the thiol-containing reagent on after we physically move the hair? Are you going to be able to put it on under the curlers? Yeah, it physically would not work, right? We physically would have to not be, we could not curl if we didn't put the reagent there first, right? Okay. So we then physically move the hair into a position we want to bind in, right? We want it to stick in. Then we're going to apply an oxidizing agent. Why are we doing the oxidizing agent now? Yeah. The hydrogens, right? We need to get rid of those damn hydrogens. We want it to be sulfur-sulfur bonds, right? So we need to get rid of the H's on the thiols. So an oxidizing agent does what? Gets rid of H's, right? Or another way of thinking about oxidation reduction, you guys are probably used to, because you're chemistry majors, you know, oxidation, taking electrons away, right? Reduction, putting electrons on there. But in biochemistry, there's another way to think about it. When you oxidize something, you remove hydrogens, or you could add oxygens to it. When you reduce something, you remove oxygens, or you add hydrogens to it, okay? It effectively does the same thing, right? Because a neutral hydrogen comes with an electron, doesn't it? And doesn't hold on to it very well. Okay. So we apply the oxidizing agent that gets rid of those damn hydrogens so our sulfurs can bond to each other, right? Now we fix them together in that curly shape, right? So what's the last part? Well, keratin's disulfide bonds will reform to hold that shape. So the last part is we've gotten rid of the hydrogens, and I had mentioned this already, right? I actually went further along. Now the sulfurs need to stick together, right? Very good. Notice the other things don't really work, so it also will help you. Keratin's amino acids rearrange into a curled conformation. Do things just like your hair actually has some weight, right? And it's going to take energy to move it around. So typically things don't just move on their own without any energy being provided, right? And this is a fair amount of weight. This would be a lot of energy for it to spontaneously move into curled shapes, right? And that's why you typically, when you curl or you straighten something, you would need to physically manipulate the hair because there's enough weight there and it's a solid, it's not going to do it on its own very easily, right? Keratins alpha helices convert to beta sheets. Okay, hopefully you guys are okay with why that's wrong. Okay, just looking at the hair, you can kind of tell it's alpha helix, right? Okay. Okay. That would be an interesting one.